All right, so question number 5 starts off by giving us 3 side lengths, and if you have side, 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 that's one of the cases for law of cosines. So some of the formulas on law of cosines help us find sides, which obviously wouldn't help us here because we already have the 3 side lengths, and then some of them help us find angle measures. So one of the angle ones says something like the cosine of A is equal to b squared plus c squared minus a squared over 2bc. And we won't make you memorize the formulas, only because, not because you can't, it's just that this isn't necessarily a skill that helps you in calculus, so like there's no real benefit of memorizing them, except maybe on the ACT, but I'm pretty sure the ACT gives you the formulas too. Okay, so the cosine of A, then let's plug in 12 for B, 16 for C, 10 for A, 12 for B again, and 10 for C again. That's what the formula says. Now, you can throw all this in your calculator if you want to right now, but it's going to be some number between -1 and 1, because that's what cosine values can be. It's not actually how big angle A is. You got a question, Kate?
Isn't C 16?
C.
Isn't it 2 times B times C?
Yes.
We're finding
Yeah. So make sure you plug in the numbers right, of course. But again, you can put this in your calculator, and this is going to be some decimal, something between -1 and 1, so something small. Be careful to not say that that's angle A. That's what the cosine of A is. So me personally, I like to just do inverse cosine and put it in my calculator this way. So inverse cosine of, okay, it doesn't really say here, but we do want degrees, so we would want our calculator in degree mode. So inverse cosine of, see if I'm finding A, that would be b squared plus c squared minus a squared divided by 2 bc. Okay, so I'm just trying to put this in here. Now, here's what I'm afraid of, and this is what's going to happen if you don't put in, if you're not checking your answers as you work along. I can hit enter here, and it's very likely to throw out some number, okay? But the problem with this is your calculator understands and follows order of operations. So, like, I don't care that it squares first, but I really don't want it to do this division before it does this adding and subtracting. What I really mean, when we write big fractions like that, it's implied that all of this stuff in the numerator is grouped together. So I'm going to put parentheses around my numerator. And all of this stuff in the denominator is grouped together, so I'm going to put parentheses around that too. So again, when we write this, we don't always write it this way, but it's assumed you do all of this stuff first, you do all of that stuff also, and then you do the division. You don't think of the division coming before the add or subtract. So we don't write it that way, but that's what we actually mean. So assuming we do that correctly, now it spits out a number that makes sense. 38.625. 38.625 degrees. Alright, so the directions are saying solve the triangles, so that means I need to find everything, all the sides, all the angles. So let's go ahead and keep on going to angle B. But also, some of these formulas, like how I found angle A here, if I end up using angle A later, if you round this and use a rounded amount, then your answer gets further off from being correct, and you don't want to do that. So this isn't going to matter on this question, But you probably want to get in the habit of saying store as A. That way we can just type in A later and have an exact value. Okay, so the only difference with angle B, cosine of B is going to be A squared plus C squared minus B squared over 2 times A times C. I probably should be going a little slower since you saw that was my mistake over here, so I just misplugged in a number. So in my calculator, I'm going to say how many degrees is inverse cosine of 10 squared plus 16 squared minus 12 squared times 2 times 10 times 16. And now I'm going to make sure I put it in the parentheses correctly. Parentheses around the numerator, parentheses around the denominator. Anytime you guys are ever unsure if you should do parentheses or not, you should just do it because it never hurts. So what I mean by that is like, you know, something super basic. 4 divided by 2. Like, you don't really need parentheses around your numerator and denominator, but it also doesn't hurt. And then sometimes you do need it. So anytime you're ever unsure, just do it, please. Okay, so inverse cosine, parentheses around the numerator, 10 squared, 16 squared, minus 12 squared over 2 times 10 times 16. Probably want to double check you're plugging it in correctly. I have to kind of bounce back and forth between my screens, so that's a little hard for me. But this is what I believe angle B to be. So for some questions, it's probably a good idea to store this as B. Again, that keeps an exact value and not a rounded value. And so then that keeps our answer exact if we have to use this for something else. But for us, we don't really need that right now. So B is approximately 48.509. Okay, now do we have to do law of cosines on the last one? What would be quicker? One more time?
Oh wait, never mind. But we could use sine cosine. Just subtract from 180.
Yeah, that's what I was thinking of. Right, all three angles are supposed to add up to 180. So if you got 2, you could just subtract those 2 away from 180. But I guess if you made a mistake here or a mistake there, you're not going to really notice it. So I would encourage you, at least in this section, to also say, all right, even though I don't have to do this for the last angle, it's going to give me a check in the end because all 3 better add up to 180. So cosine of C would be a squared plus b squared minus c squared over 2 times a times b. And again, if you put this in your calculator, that's not angle C. You have to do inverse cosine of that to change it from cosine of C equals to C equals. So inverse cosine of 10 squared, 12 squared, 16 squared, 2 times 10 times 12. Okay, and looks like that angle should be about 92.866. Approximately 92.866. And again, even though law of cosines is completely unnecessary in the last step, if you know the formula, or if you look at the formula correctly, it doesn't take that long to do it. And again, now I've got to check. I can take my answer for angle B, add my answer for angle A, and finally add my answer for angle C. And it better come out to be exactly 180 degrees. And it did. I just checked it on my side calculator. Whereas how I almost plugged in a wrong number for A, well, luckily my calculator realized something was wrong. But that would help me catch that something was off, and I could reevaluate my work. So question 5 is great for finding all three angles given all three sides, law of cosines.